All right, how's everybody doing? Good? So everything I'm going to do today is completely irrelevant now that Claris Connect is coming. No, I'm just kidding. It's actually very, very relevant. But if you feel that way, you know, if you're sitting down there, sitting and thinking that, wow, we've spent all these years building stuff, and then we may be looking at a whole new generation of way of doing things. And what do I do to move into the Claris Connect world? Guess what? I'm in the same boat. Okay? So, but it's an exciting future, and I'm looking forward to it. And I think that I'm hoping today that I can show you a few things that we're doing in preparation for the change that's coming. Right? So, who am I? My name is Ernest Ko. Well, no. Sorry, I was just waiting for people to come in. My name is Ernest Ko. Let's try that again. Who am I? I'm Ernest Ko. Yeah! There we go. I'm the co-founder of Proof, also co-founder and of Pause and Error. For those of you who've been to Pause, you know me. Florida man. I literally live in Florida, so I can tell you all about Florida man. If you don't know about Florida man, go Google Florida man. He'll be your friend. Okay? Myself and my team, we've been doing this for quite a while, and I would like to think that we have run into all kinds of interesting FileMaker problems at scale, right? And that's kind of the thing that I think we focus on. So things happening in the enterprise, things happening at scale. How to make FileMaker do often things that FileMaker isn't designed to do out of the box, right? And yet find the balance between letting FileMaker be FileMaker and extracting the best value out of it, but also solving problems in the real world, right? So one of the problems that I've been thinking a lot about, many, many years now, is the problem of search, right? And I want to make a distinction between search and find, right? What's find? Command F, right? What's search? Well, for me, I like to define search as really a user experience problem, all right? And find is really an implementation, a method of querying records in a FileMaker database, right? I'm a big fan of find, right? Command F is your find. In FileMaker, I think that that's probably the biggest unsung hero, right? The idea that you can expose the layout, let a user go into it and click find, and magically things come back at you in sort of an example kind of way. Very, very few systems in the world, I mean, yeah, almost no out-of-the-box canned solution in the world does that, and does that well, right? FileMaker does that amazingly well. And I know that as a community, we struggle between wanting to lock it down, you know, put your own UI on top of it, or to expose it. Right? I don't see it as a dichotomy. I see that as, hey, what we're really trying to do is do two things, right? We're trying to do a search experience, but what we have is the FileMaker find mode. Yeah? Right? So, show of hands, how many of you expose Command F and find to your users? Oh, that's pretty good. How many of you are building interfaces to do searches and lookups and other things on top of that? Okay. Now, is the latter fast or slow? Well, I don't know, you tell me. Yeah. Maybe sometimes slow, kind of tricky, right? Well, believe me, I've run into all of those situations, right? Because, and what we're about to do today is really to, you know, what I want to do today is really to take you through sort of my story of how I'm kind of thinking about find, and talk you through where we are now, and kind of work backwards and kind of talk through the process of getting where we are, right? So before I get to the basic stuff, let me show you the end of the story in case you fall asleep and you want to step out. Let me tell you where we're going, and then I'll come back and talk about how we get there, all right? So I'm showing you a real-world example of a solution here. So let me set this up here. This is about processing incoming form data for a very, very large school. And we work a lot with schools, and so one of the classic problems that they have is you've got all kinds of sources, inbound sources that receive data about applicants and inquiries and so forth, right? You apply for a school, you get a name, and then they have amazing amount of data they have to sieve through. And the problem that we need to solve is how do you check that name that's coming in or that application data that's coming in against your existing database, right? We don't want to just create a new record for the most part, right? Because the quality of the data is really important because they're using it as a CRM. They're using the data to prospect, right? Where they live, who they are, the email addresses, the content and the quality of data, not duplicating the data is pretty important, right? But if you think about what a school or any business that has a similar kind of problem, you have all kinds of data coming from all kinds of different places, and sources are not normalized, right? Things are not in the same format, they're not in the same field labels, whatever it is, right? And you're going to have to coerce everything and match it up to your database, right? So again, this is a snapshot of where we are now. I'll show you sort of the performance experience of this. Again, just imagine, in fact, this is hundreds of thousands of records in the back end that we're matching against, right? And as I'm flipping through my new incoming applications here, you see the thing that's on the right-hand side? This is in real time doing a live query to return the ranked best sorted match in the system as they come in. Okay? Pretty fast? Yeah. And this kind of feels like Google speed, right? Like you're typing the thing and bam, so you got a list of records that you can pick from, right? And again, obviously I don't have a search UI bar or anything like that up here because I'm literally querying all the content of this form that I'm going to use as search terms and displaying the best match on the right-hand side. Right? It's a multi-parameter query, getting a result from multiple databases back in my system. Right? All right. So you want to know how I did this? Okay. Okay. So it's not in FileMaker. Okay. But it is. Okay. And we'll get to the core mechanics of it, but I want to underscore one point here. And you know, if you've been to any other session in this conference, you've probably seen stuff around REST, Data API, curl, you know, all the non-traditional kind of FileMaker things, right? And it can seem really overwhelming because it's not the same FileMaker we've been used to, right? It's doing something outside an external source and then kind of manipulating and dealing with it, right? But I'm going to make a case here that for very specific problems like search, for example, not find, but search, there's a really compelling reason that we need to expand our horizons and look at things that are really optimized to solve this problem, right? So to give you a quick preview, the way we're doing this now is we're spinning up what's called an index engine, right? We are in the background running another server, not a FileMaker server, but in this case a document search engine. Now there are a number of those out there. The one that I like to use is Solar. And we actually have deployment scripts that we run alongside our FileMaker scripts that spin up these instances as companions to FileMaker servers, right? So think of it as a shadow database that captures data from FileMaker and makes it find really, really fast, all right? Now, the beautiful thing about this is Solar is free. It's open source. The other technologies like this called Elasticsearch is one of them. And it's a class of document search and indexing engines that are pretty easy to set up, right? So that's the good news. You need to know a few new technologies, but for the most part, you can install it, especially with Elastic. There's an installer, there's good documentation. You can really kind of do it yourself, right? You can get a long way getting this spun up. But fundamentally, what we're doing here is we're spinning up a search server and saying, we're going to let FileMaker be FileMaker, and we're going to do indexing as a separate problem outside of FileMaker. All right? So far, so good? All right. But I'm going to pause there. I'm going to go back to square one. Right? I'm going to go back and talk about why we need to do this, and kind of break down sort of the thought, you know, the thinking that's kind of led us to this point. Right? And I'll say that before I get there, this is just the beginning of search. the future is really bright on this because if you don't like spinning up your own search engine, imagine what Clarus Connect can do for you, right? You can just adopt a search service using triggers to push the data over and to get results back. Right? So that's where I'm going to try to get to. All right, so let's get back here. So basic stuff. I'm guessing most of you know this, but it's worth repeating, right? FileMaker finds are really fast if your data is indexed. FileMaker finds are really slow if your fields are not indexed, right? Pretty basic 101 stuff, right? But it's kind of a paradox, right? If you need to search across multiple tables, very, very deep structures, you wind up trying to index perhaps a lot of things that will blow up your database and kind of make it slow, right? So I think in the FileMaker world, that's the tension that we're always kind of balancing, when you index something, when you don't index something, right? But there are other things there's some other nuances that are worth kind of reminding ourselves about too, right? Finds in local fields, meaning inside the table in the same context you're on, that's lightning fast, especially if it's indexed, right? What about finds in related fields? Well, it kind of depends, right? I mean, you can have index fields in related tables that are lightning fast because the joins are very cheap. You can have index fields in related tables that are extremely expensive because the joins are expensive. And if you have multiple hops and multiple joins in your find path, that becomes more and more of an issue. And there are tons of benchmarks that have been done around this. So I'm just giving you a broad survey of sort of the conventional wisdom that we all know to be true today, right? And this quirk in FileMaker where when your joins get to about 5 or 6 deep, things get really, really funky, right? It's like, well, at 4, it's perfectly fine. Then at 5, it goes bananas. And why? I don't know, right? So you got to watch out for that. So again, it's a kind of a tuning question, right? And a lot of it is how FileMaker has to build this dependency tree, rebuild the join in memory, and then do the find and query on your behalf to return results to you. Right? So far, so good? All right. So again, this is sort of the basics of find, right? So when we looked at this problem of, hey, we've got hundreds of thousands of records, we need to do finds on them, or we need to do a search on them, give the user a ranked result set that gives them the best match against their data. How do we go about doing it, right? So let me take you through sort of the things that we've tried, right? We know finds are fast. We know unsort finds are slow. What about quick finds? We all know what quick finds are? Okay. Quick finds are kind of like magic, right? Because if you stick a field on the layout and you expose it as a quick findable thing, FileMaker just does a find across all the objects that are enabled for quick find, right? And I'm sure most of you have kind of used this to great effect. So I'm just going to do a quick example here. So again, I've got 100,000 records in here. Can you guys see this? And again, I think this is fairly, I don't know, does it work? There you go, right? So that was pretty fast, right? And what am I finding on? If I look at my layout mode and I hover over here, I can see that I've got zoom. Don't want that. Okay. So I know this is a little small, but for those of you who are new to this, this little checkbox here is your friend, right? Including quick find. Again, this is fairly basic, but fairly important stuff because we still use this method in a lot of our solutions. It's free. It works incredibly well. So anything that you expose that you check as being capable of being included in the quick find, FileMaker is going to do this on that context for you. Right? All right, so again, I'm going to do the same thing, type Ernest. I just added 3 or 4 fields to that find, and it's lightning fast. Right? Well, what's the problem with this? Well, it's nice. What if you wanted related data included in that? Could you do that? Absolutely, right? You drop a related field and off you go, right? What you want 10 related fields off of this context for related tables? Well, drop more fields, right? What if you have 1,000 tables across 4 databases, right? Put more fields on the layout? This is where it gets dicey, right? So quick finds can help you, but there's a limit to which the number of queries that you have to do on that layout against related data become an impediment to the performance that you're trying to achieve. And again, there are tons of benchmarks around this, and you can go Google and search for them. But the problem is, again, the more joins you have, the more FileMaker is resolved on that query, and that has not a linear impact on you, that has a geometric impact on your search experience. Right, so search experience on shallow stuff, perfectly fine. Search experience on deeper stuff, kind of problematic. But nonetheless, quick finds are pretty awesome. So if you don't know this already, back in the old days, people jump through a lot of hoops doing things like type aheads with portal filters and whatnot. With quick finds, you can get some pretty amazing experience. You can see I'm doing this JA. Let's do C. This is just quick find, guys, on 100,000 records. I mean, it's like nothing, right? And you want to see how I'm doing this? Is this, okay, I'm guessing. So this is just a trigger, right? I've got a script trigger over here, and it's running, there we go. It's running on an object modify on the input field, and this is calling a script. And what do you think that script is doing? It's quick find, right? I mean, it's so simple, it's almost like cheating, right? And I say this to my team often, as developers, we often want to look for like the special, sexy way of doing something, right? If it's got to be a portal filter, it's got to be some expensive query, some SQL or whatnot. But man, if you can get away with quick find, please use it, right? It's built in, it's lightning fast. You can put things on and off the layout, turn things on and off, and you're done, right? So let me go a little deeper here and show you what that script looks like. Let's see, quick find. On keystroke trigger, okay? Not counting the exit, not counting the error capture, 3 lines, right? Well, once you put error trapping and all that good stuff into it, it could be like 50 lines, but right? The core mechanics of this is just 3 lines of script, right? I dare you to do that in JavaScript, right? So I'm, again, it may seem like I'm pretty gushy about this kind of stuff. As FileMaker developers, don't be shy about like the basic stuff. I mean, go back and review your code, look at where you've done some fancy pants technique, and just think for a moment whether or not that can be better served with something really basic and really quick. All right? So quick finds are awesome. I'm just getting a keystroke trigger, and I'm doing a quick find, and then returning the results. And of course, if that wasn't obvious already, this is a 1718 layout, so this portal here is really just is from the same context. This master detail list that I have on the left-hand side, that's on the same context as the thing that I'm finding on, so I'm just seeing the list automatically, right? I don't have to do any virtual listing. I don't have to go to a separate layout and gather stuff and put it back in here. It's just all right there. It's kind of brilliant, right? Awesome stuff. Right? So what's the problem with quick find, or finds in general? I mean, by the way, anything you can do with a quick find, you can do with a find, right? You just have to add more lines, almost everything. What's that? Operations, yeah. You have to add, well, if you want to get fancy with omits and stuff and logic, then you would have to step out of the quick find idea. But in terms of providing a search experience, right, quick find gets you a lot of juice. So far, so good? Feel pretty basic? Okay. So here's the question, right? What are the problems with this technique, right? Why do we need to go beyond this? Now, if you recall, I started with my interface where I have a form on the left-hand side, a whole bunch of data, and a whole bunch of results on the right-hand side, right? So in a complicated scenario like what we were showing in the top of the hour, sometimes it's not as simple as finding on a single term. And moreover, sometimes it's not as simple as just returning a list of results. Because what you want to do is return the best matched result that you can find. Right? So the question is, well, how do we do that? How do we extend quick find to achieve that? You just think for a moment. What needs to happen? Well, for one, you need to sort the list that you get back. Right? This list here is unsorted. It's just in the order of the found set. But what do you sort it by? Alpha, right? I mean, you see where I'm going with this, right? If I type Jacksonville, how do I know that Michelle Fokar, I guess, is the best Jacksonville match for my search term? Yeah, that's the question, right? So in FileMaker, we lived in this word a lot, right? We do a find, well, it's the first record, right? Right, and your customer asks you, well, that's great, but I want it sorted. And you go, well, tell me precisely how we want it sorted. And so we go about coding the sort, well, we'll sort it by zip code. And then they tell you, well, no, zip code is fine, but it doesn't match what my real intent was, which is like relevance. Right? So the question is, and the core question about search, which is different than the problem of find, that's a distinction, is that search has to handle the question of relevance. Does that make sense? Right? Right. And relevance is like Google, right? You type in, the world is about to, and it shows you N, sorry, I'm about to have a birthday, whatever, right? So you see the list of results that come in a Google search. That's relevant search. Google understands that your search terms you typed into the input field is doing more than just doing a text search on the index values in the system, right? By the way, if you don't already know this, FileMaker indexes things in how many ways? Two ways, right? It's in value index and word index. And the distinction is the value index is the entire value of the store, the field store. The word index is the individual words of that value that have been kind of decomposed, right? So it really has two tokens. And I'm bringing this up because there's an important concept here called token. There are really two tokens in the FileMaker find approach. One is everything or chunks of everything. That's it, right? There's no chunks of everything. There's no French version of the chunk of that thing. There's no fuzzy version of that chunk of that something, right? So when you find something, you can get earnest, if that's the term you're looking for. If earnest appears in one of those chunks, either as the value of the word, you're home. But if it's Ernesto or something fuzzy like Ernest spelled with a misspelling, then things get a little weird, right? So the problem is if I'm typing in Jacksonville, this is bad, right? Because this ought to be relevant. With me so far? Right? So how do you go about solving this problem in FileMaker? How do you go about handling sort of a relaxed search situation and to give your users a way of not being perfect human beings? Well, I've been trying to solve that problem. So where we started was we thought, well, gee, okay, seems like if you're going to relax your searches, if you want a real relaxed searching thing, we have to broaden the way our tokens are matched on, right? So if I type in Jacksonville, I need a way to know that Jacksonville, spelled correctly, is close enough to the result that I want to bring back, So one way to do this is to use some functions, right? Is to use some comparison functions. To say, okay, from the list of results that I've gotten back, either rank them by some relevant score and compute that score and then produce a list sorted by that search result, right? And again, if you want to research this, go look at stuff that I've done in the past, also Matt Navarre with FM search results, and there's this ton of work being done in this area in the past. And the two things that will come up all the time. One is Soundex and one is Levenstein. And if you need a reference on how you spell those, they are in the slides, and you can go check that out. I don't remember where I put them. It's in there somewhere, right? So Soundex and Levenstein are sort of the two traditional ways you apply some kind of ranking methodology to your return set so that you can sort the results by some kind of relevance score, right? So I think the obvious question is, well, how do you do a Levenstein function, right? So I'm going to code this right here for you. No, I'm not going to do that. I am instead going to say that there are custom functions out there that will give you a Levenstein function. So that's one thing. But we've had a custom function that we've built internally and have had around for quite a while that I'll just show you what that looks like here. Oh, let's see. I can't even see my own screen. Sorry, guys. My search problem starts here. I know some of you understand this issue. So I have a function here called PGLG distance, text1, text2. And again, I'm just going to show you sort of the mechanics how this works. And if we do ABC and ABCD here, what this will do is return. So ABC and ABC, you guys see this? Returns what? 0, right? So what this is doing is computing an edit distance between those two terms. Now I can't see you. This is terrible. It's computing an edit distance between two terms, all right? It's saying, what does my term on the left look like compared to the term on the right? Right? So if you imagine if I do ABCD, what happens? Pretty cool, right? So it gives you a value of how far that word is from this other word. By the way, we're releasing this function open source, so you guys can go download it. We'll be in the keynote deck and whatnot. So if you don't want to write your own, you can just steal what we've got, right? But the real world scenario that I was talking about is something like this, right? Jackson, there you go, like that. So here we've got Jacksonville with a misspelling, and it's a score of 2 away from the term that I want to match. Now this is pretty useful, right? Because if we can use that as a way of computing how far it is, what the score for that search term, then I can rank and sort and search the search results, right? So for years, for a few years, we relied pretty heavily on Levenstein and Soundex. Soundex does a very similar thing, but it's matching not on edit distance, but it's matching on the sound of the word, essentially, right? So Ernest spelled with the E-A-R will match Ernest spelled with the E-R. And that's pretty handy, right? So people who are typing in Jason Lee and you don't know whether that should, L-E-I-G-H should be as relevant as L-E-E, you can use Soundex to add it to your relevance score and so forth. So over time, if you go down this path, right, if you're sitting at this point of trying to figure out how to build a relevant search engine in FileMaker, you'll probably start with, oh, let's do edit distance. And then 2 months later, you'll say, oh, I'll add Soundex to this. I'll compute a score, and I'm gonna build a rank for my search results. And then and so forth and so forth. You start applying new filters to your search results to add more scoring capabilities to your results, right? And then what you get is, in the end, a result set that lets you sort this list that I have here, not by the standard FileMaker sorter, but by the rank score that's been computed. Make sense? What's the problem with that? Stop. Say again?
The difference between the size of the word and the score. Like if you've got a three-letter word with a score of 2, it's very different than a 12-letter word with a score of 2.
Right. So that's excellent, right? So it's kind of brute force because it doesn't know your intent. It only knows that it's different, right? That's one problem. And that may be good enough, right? With other factors in your rank score system, you could tweak your weights, so to speak, to get to a point where you get a close enough proximity to what the user's intent is, right? So let me show you what I mean here. I have a system here that, I don't know, I'm kind of afraid. The problem with these things was, the problem with demoing search, just FYI, if you ever do this in the future, is that you're working with lots and lots and lots of data, and if you screw up, things go bad, right? So I'm a little nervous because I don't know if I totally messed up some script while doing this example, but we'll try, okay? Let's see. Do I dare? There we go. Okay. So I want to show you a real-world example of how we use search factors to compute a relevant score. And you don't have to memorize the script. There's no test for this. You can do it your way. It's totally cool. But I just want to get this to a point where I can show you. There we go. Bear with me just a second. There we go. All right, don't move. Okay. You see that mess? Don't do this. Okay. But again, this is pretty old code, but I'm giving you sort of the archaeological dig of our thought process as we've gone about trying to solve this problem. And the way we went about doing this was to brute force apply Levenstein distance and other search scoring mechanisms to arrive at a computed rank score, right? So we're trying to compute relevance. And so I asked, what's the problem with this? Well, one, as the gentleman answered, LD is not necessarily the best way of computing relevance. It's only one way of computing relevance. So then you got to bring all kinds of other ways to make that relevant scoring system a lot better, a lot stronger, right? So, well, then you got SoundX, so you throw that into the mix, and then maybe you say, well, I want to treat email differently because email is special, so you throw that in the mix, and hey, well, I want to treat Chinese names differently because of a business use case, so you throw that in the mix, and hey, by the way, this is an image. Well, now I'm totally screwed, right? So, you know, if you look at this example, we've tuned this particular search thing. Again, don't do this. This is an example of what not to do. We had at one point tuned the search engine, the relevant scoring, so that it gets down to things like, hey, if I've got a birth date, bump up the score value. If I've got a match on a gender term that's exact, bump it up so that I push it up higher on the list, right? But the fundamental problem with all of this is that when you do these sorts of computations and calculations in FileMaker, what kind of store value do you get? Trick question, right? It's unstored, right? What happens when you sort on an unstored value over 1 million records? Remember why I was scared? Well, that's why. So, for small data sets, you know, sub hundreds, 50,000, you know, 10, you can do whatever you want. You look like a hero, right? You apply Levenstein distance on a 100,000 record data set with a pre-search filter to get an initial set that you can rank on. You're king, right? But the moment you start to have to look across multiple tables, related data that has complex joins, this becomes extraordinarily computationally intensive and non-performant. So I feel like I've been bringing bad news all morning. Right? How many of you feel like you're exactly in this place right now in your solution? Nobody? Wow, that's awesome. You guys all figured it out. So let me go on. So again, we're taking a walk through history of how we've attempted to solve this problem. All right? But I want to go back to my examples here. So quick finds are awesome. Quick finds with relevance scoring, not so awesome because it gets expensive. But then, with FileMaker 16, FileMaker 15, 16, 17, as the old new tech started rolling out with things like JSON and data API, we started thinking, well, maybe that can help, right? And maybe, well, let me back up for a second. One of the problems with quick finds is that it's great, but when you have a context-independent problem, like I was describing, you have to go and kind of assemble a lot of things together to kind of bring it back into one place, right? So, for example, if you're searching invoices, customers, and line items, how many contexts are you looking for? 3, right? How do you aggregate all of them back so that your view looks like a search experience? Virtual-less, you loop through those records, you gather them back, and you stick it into one place, and you can kind of decompose, right? Pretty standard kind of FileMaker-y kinds of things to do, right? But it's not cheap, right? So you can do a context-dependent search experience pretty easily in FileMaker, but context-independent search experience gets kind of dicey, even without the ranking stuff or the relevant scoring stuff and all that. So that's not a problem with finds in general, or quick finds with respect to search. Right? So we've got 2 problems now. We've got relevant scoring, and how do you break context dependency? Right? And a lot of you may be thinking, well, gee, we'll throw a global on there, and then we'll just let the user type into a field, right? So the experience that you want is something like this. Let's see what I can do is, right, so like a quick find, but instead of actually looking at a quick find layout to do the find, you may have a portal that you're doing some kind of related match on to kind of pull the results back, right? And again, you may have 4 or 5 different portals that you're kind of filtering on and aggregating to get the results back with the portal filter kind of technique. But they all suffer from the same problem, right? That's one way to get context independence, but you still have a performance issue, right? So, we've been beating our head around this problem, and we've tried a lot of different things. And one of the things we tried is, well, why don't we, well, first, let's see, how bad it is with quick find to do context-independent search, right? Does it get nuts for us? So I have a quick example here. I've got this is just JSON, by the way, so it looks scary, but there's a reason why it's up there. But I have a portal here of search results, and I'm going to type, let's hope this works. Okay. I'm going to type, maybe, Jax. I don't know. I think I broke it, but whatever. So, there we go. So, that was a quick find across multiple contexts. All right, and what's happening here is that this is a global layout that has nothing to do with the context I'm doing a find on. And what's happening is that find is then getting dispatched to multiple layouts to do the find to then return it into some kind of list. Right, I'm going to show you the script that does that work. Again, this is not a code deep dive. I just want to give you a sense of how that technique works. So I've got a script here called quick find and aggregate. And all I'm doing here is going to a context layout to do the aggregation, to do the find and do the aggregation. Then I'm going to the address layout to do the find and aggregation. Then I'm bringing it all back into one place as a JSON packet, as a JSON object. And then I'm using virtual list to kind of decompose that, to parse that, to give you that list view in that portal, right? So the good news is it's actually pretty dang fast. You can get a lot of mileage just doing that. Now, before, when JSON functions were not natively supported, it's a little dicey, so people use like list delimited stuff, but that's problematic because then you have to parse that, and you have labels and values that you kind of decompose. It gets pretty gnarly, right? So JSON's your friend here. If you want to do this for a well-structured database that's not very deep, this is actually a pretty good way of doing it, right? You still have so you've achieved context independence this way, right? Let me back up for a second. So if you see what I'm doing here, I actually have in my script called aggregate contacts, the meat of it. Again, it's a very, very simple script. This is not production quality script. Don't copy and paste this in your code and say, Ernest did it this way, so do it this way. This is just for demo purposes, okay? This is just to show you the heart of what the mechanics look like. Right, all it's doing is going to a layout that supports quick find. It has the quick find fields on it, and it's just doing a quick find. And then it's doing one other thing on top of that, which is what? It's looping through those records. Again, you say, well, there are better ways to do that. Yes, there are tons of different ways to do that. You can do summary list function, but be careful. You can export it out and do it back in, whatever. You can do whatever you want, right? The point is you're aggregating that result set and bring it back into FileMaker in the end, right? So here, again, I've chosen JSON because JSON's an object, and objects are traversable, and objects are parsable, and objects are easy to manage, so you don't have to think about how you're parsing that data. So for every object that you want to support a quick find on, just throw this kind of script on it, and off you go. And then you've got a multi-context, context-independent find search experience. So yes, so you can solve the context-independent thing with quick finds, but you're still stuck with the relevance problem, right? Because once you've got the results back, so now you've got this big thing of JSON right here, right? And you've got a virtual list table that reports all that data out as rows. So this is every row of that big JSON object that I've gotten back. You still have to score every row that's come back, right? So now we're back to, let's apply Levenstein, let's apply SoundX, and then we got to calculate unstored calculations and then rank them. Now, and the killer is, you can't just rank the list of items that you want to see, right? You have to rank the entire data set that comes back before you do anything with it, right? So the bottom line is, when you get to this level, if you don't need relevance scoring and to support your search experience, you can stop here, okay? But if you need some kind of scoring mechanism, you have to look elsewhere, because there's no way to compute that in FileMaker that's not expensive. So that's a bad news, all right? So let me take you fast forward to where we are. So what we've done is we have moved towards a system where we are spinning up essentially a shadow search engine. Again, it sounds like such a crazy idea, but search engines are open source software today, right? I mean, it's stuff that anybody can download and use. It's not, and because FileMaker now has REST API support and curl and all that, you can interact with search engines that support REST and data and JSON standards. So it's pretty easy to get data in and out, right? But the basic idea is we spin up Solr or Elastic in some cases, and we run an indexer in the background to cache the data. Right? So all it's doing is running a script to feed this little monster here that keeps as many records as you want indexed in a document index system that you can do a find on. Right? You want to see what it looks like? But it's not very sexy. But it's kind of cool. Let's see. Index objects party. So this simple UI here. Let's see. This simple UI here is basically a little thing that we have running in the background, and it's just checking for changes in the system by mod timestamp. And it's just keeping a hash, and you can do this as a robot, you can do this as a server-side script, whatever it is. It's just running periodically to catch up on all the changes that have been made in the system. And we actually aggregate a ton of data in this, not just one record, but hundreds and hundreds of tables, build different shards of documents, and then we kind of shove it into the index engine. Then you can search on it like you're searching against an instant database across the system, across your system, right? So again, this is not for copy and pasta code. Just to give you a sense that the basic idea here is you want a way to capture the changes and then to kind of shove it into the search engine. And you do all that mostly with just REST calls, right? How fast is it? I can do 100,000 new records to load, 200,000, I think this is like a 4 or 5 table database that's pretty deep, pretty expensive. The whole thing in about 15 minutes, initial loading. And the actual refresh of each record as they go in is milliseconds. And the find that comes back is we don't have a sense of like web scale, but it operates at web scale, right? These are millisecond operations that go back and forth, So to show you what it actually feels like and look like, here's a simple backend interface that we can, you saw that? I typed in Mike. I'll type in Mike. I'm going to hit search. Bam. This is over 200,000 records that's going through, and not only is it looking for the documents that are in the system that have been indexed, it's scoring, ranking, and computing a relevant score on the fly and returning it into the system. So you will see here at the bottom that somewhere you got this score value that I've added to that. Right? Is that pretty cool? Right? You can do this too. All right? If you can't call me, but you can do this too. But there's some caveats, and I want to give you a roadmap of how to kind of figure this out, right? One, it's not magic. You have to in most of these search engines, you have to configure a schema. You have to tell the search engine what does that data look like, okay? And a lot of these systems, like Solr or Elastic, I'm almost done, it's okay. Like Solr or Elastic, they have an admin console that's a web UI. You can go in, you can import data into it, and you can kind of play around with the query parameters. I have a core here called proof. You can see that in this example, I've got 70,000 records or so. And you can actually run dry run schemas and do queries within them. It's pretty cool stuff, right? Again, this is searching against live data, and it's actually searching, in this case, it's actually searching on my local computer on my dinky little laptop here, but this performance is almost identical on a hosted server in AWS, in your on-prem solution, or whatever it is, okay? Pretty cool stuff, right? So I know I'm running short on time here, so I'm going to kind of bring this to a close. The moral of the story is, we're not done with this. I think search is a very, very deep domain, and even as cool and as exciting as this has been for us, and we're using it a lot now, there are still problems, right? And not the same kind of problems, but there's problems of achieving just the right, for example, tweaking the relevance score in these search engines can be kind of voodoo, right? It's not exact science, it's more like art. You kind of have to know what your data looks like and how you weight certain things and how you query certain things, right? So there's no like one-stop recipe where you turn it on and boom, everything just works. You kind of have to understand how those scoring systems are actually computing the relevance score, and you got to tweak it to get it to match correctly, right? So that's one caveat. And two, the future is actually probably not just these kinds of search engines. There's AI that's coming. You hear Core ML that's involved in this. There's also natural language processing engines that will do a lot of this stuff for you, again, with APIs and whatnot, okay? So the cool thing is, if you build your solution for external search, in theory, you could plug and play new search engines as they come online, right? And if we ever get to the App Store, it'll be cool to just be able to like click plus, and bam, have a search engine that you can load up. How does that sound? Pretty cool? Yeah, all right. All right, guys, I'm done. Have a great DEF CON. Slides will be online. Oh yeah, questions. If you guys have questions, sorry. Yes? The question is, do I use a user key for external search? So yeah, it's a good question. There are services like Elastic.cc, I think, is a company. Elasticsearch, yeah. Elasticsearch has a service you can sign up, and you don't have to deploy or manage any of your databases or your search engines yourself. It's all like a nice charge. Okay, I'm gonna give the early exiters just 2 seconds to clear out, and then we'll do questions and answers. Okay? And feel free to come up, and we'll just chat. Okay. So, do you need me? Yeah. So there are two questions. The first is, do you need a key or a user key? Do you need to sign up to a search service to do searches, to do the kind of searches I'm doing? The example that I have was me deploying our own search engine, right? So in that case, you don't need a key. Now, you need to do certain things to make it more secure, but you don't need, say, a key to like use that service because it's your thing, right? You can host it and do your thing. But the cool thing is, if you don't want to do this by yourself, there are services that provide search engines as a service. Elasticsearch is one of them, right? I'm a big fan of Elasticsearch. They're not free, but it's pretty inexpensive for the kind of things that you want to do. And you can go look at the docs and kind of do the same things I'm doing now with REST API calls and so forth, right? So if you want to get started, an online search as a service platform like Elasticsearch is a great way to get started, you know. If you want to deploy your own search engine like Solr or Lucene or Elastic, even it's open source system, you can do that, and that's what we're doing. We actually have an Amazon Web Services farm where we spin up new instances of search that kind of pair up with our FileMaker implementations, right? Thank you. Appreciate it. Thank you, guys. So the second question is FileMaker 18 performance. FileMaker's fine performance in FileMaker 18 is significantly faster in some cases, right? I think, are you guys seeing that? I feel that. I haven't done like full benchmarks on it and whatnot. And I think they've done a better job at the back end to distribute the search and not lock CPUs and stuff like that. I don't know what the voodoo is, but it sounds like that's what's happening, right? But the core problem here is on index searches, that's great. But what about unstored ranking calculations and so forth? The client still has to compute that work, right? So this is the core problem with unstored calculations. You're actually doing a lot of the computation at the client, on the client level, right? Because you're drawing that view and you're sorting it and you're ranking it, and so your client's actually doing that calculation. So you get an incredibly fine engine in the back, but if you can't compute that relevance scoring and get it back, you're kind of toast. Now, you say, well, I can do it PSOS. Well, PSOS is great, but how do you get the data back? Right? I mean, the score is, you would have to kind of loop through that data set and return it as some object that's already pre-ranked and return the rank to it and then kind of reference it in some other way to get the search result. So it's complicated. So yes, finds, quick finds, especially with FileMaker 18 and whatnot, you get a lot of mileage out of that. Yeah, and it's awesome stuff. Yep.
I was wondering if feeding in the changes to the indexing engine in real time, or
Yes. Yeah. Yeah, leave it to you to ask that question, Tom. Both. So we're not hashing. We were hashing at one point, right? And so I think the question is, how do you know what's changed, right? And this is a tough problem in FileMaker because, well, you have modification date, but that's not the same thing as what's changed, right? If you have a database with one field called name and the name's Ernest, and you went in there and typed in Ernest and then backspace and typed in, took out the T and then put the T back in, has the record changed? No. Has the record been modified? Absolutely, right? So if you rely on modification date and timestamp to kind of figure out what's different, you have potentially a lot of changes that don't matter. And so your indexing engine has to work that much harder to kind of pull in the things that have changed. So that's one problem. The other problem is that frequently when you do this, you're not indexing one table, you're indexing an object. And by that I mean, let's say a person has 4 addresses, 5 phone numbers, 3 birthdays, no they don't, 3 relationships or whatever it is, right? And that object is what you want to shove into your search engine, right? Well, how do you detect change across multiple tables? If the phone numbers change, does the whole document change? Right? So we went round and round in this, and for a long time we said, I just hashed the whole thing. So we would do this. You guys know what hashing is? Right? So you take a bunch of text and you spit up some signature and you just compare signatures to see what's different. Right? But hashing across related tables and records means that you've got to go through and do some kind of computation and store that compute, right? So now you're trading off the time it takes to do finds for mods for time it takes to hash the data. And the killer is, if your schema changes, what you got to do? You got to go back and rehash the thing or rebuild that hash, and then that has a whole pile of problems associated with it. So we've actually moved almost entirely away from hashing as a strategy. We've just relied on putting a whole bunch, actually quick finds. We've put all the mod dates on a layout that represent the document that we want to index, and we just find on them. And as I showed you, if your solution is well architected, you're doing one find and one related field across multiple tables, lightning, right? So the thing can just go back there and just do finds on what's changed, what's modified. And so we don't get actual changes, the deltas, but mod's close enough, and that's what we've done.
To deploy the party model effectively, sometimes you have to cache data in multiple entities.
Yeah.
This eliminates some of that because you don't have to replicate it.
The reason we've been banging our head on this is because we've been deploying party models since day 0, right? I mean, that's the proof thing. I mean, hundreds of thousands of records, party model, lots of different relationships and objects connected to it. So yeah, that's exactly right. It allows us to have, so the classic problem in FileMaker is it's the choice between, it's like a Faustian problem, right? It's a choice between the right model and the wrong search, or the right search and the wrong model, right? If you build it for speed, you make all kinds of compromises about your data model. If you build it for scale and correctness or non-anomalous data design, you trade performance for that, right? Like I used to be able to do this fine because my address field was in my local table and it was lightning fast, but now address is 2 hops away and you're kind of screwed. But you know what? You can store 10,000 addresses without a blink. So what do you do, right? So what we did was say, well, let's model it right to the domain and then solve the search problem separately. Because in my mind, it's always, it's hard to fix the wrong model. Well, search is hard, but fixing the wrong model is almost impossible, right? And that's like your business doesn't work because you're not storing data in a way that makes sense. Right? Other questions? In the back?
Hi there.
Yes.
So, question that's probably a given for a lot of people, but for me, being just a little bit greener, I need something explained to me. Why is it that using a lot of these features like JSON internally and searching is better than just letting FileMaker use its own native search tools? It seems like adding a step. What's wrong with FileMaker native search system?
Nothing. In fact, that's exactly what I was trying to say, right? If you can use native search in FileMaker, use it. But I think your question is a little bit more nuanced. I'm not searching with JSON in FileMaker. Like I'm searching a separate database and returning the data as JSON.
Okay.
See?
That makes sense.
Okay.
Thank you.
Others? Stephen?
What about searching across with, you're looking for billing, but email or mail, those kind of additional parameters instead of just
In an engine like Solar or Elastic, that is easy peasy. I mean, because you can relax the search. You can do things like send a query parameter over and say, terms can be either this or that, or nothing. Yeah. Not free, but easy. Yep. Yes. Yeah. I'm going to post my demo file as just so you can just like rip it apart and do whatever you want with it. Yeah. But just know that it's not production code. Don't copy paste in it.
You said Solar was a separate server?
Yeah. So I didn't get a chance to show this, but the
Married or put on the same server?
do not do that. Right. Do not put it on the same server. Keep FileMaker server and your Solar server separate. Solar is web technology. It's actually Java in the background, but this is the website. Yeah, sorry. I don't like it that much. That one, yeah. Okay. It's open source. It's free to use, and so forth. And there are others that we'll play with, and to get started, Elastic is probably the easiest. Solar is probably the next step. But I would recommend not deploying the search engine alongside your FileMaker system, right? And the reason for that is even though Solar does a lot of its indexing in memory, it will from time to time still have to persist the data back to disk. Right, so anything that has anything to do with persisting data back to disk and you're competing for FileMaker time, don't do it.
So if the FileMaker server is running on a virtual machine, so it could be a matching virtual machine
Yes,
that they could then decompress?
yes. It's more important is on a separate volume, right? I mean, like it's the persistence as an issue, not the compute, right? Okay. But that said, Solar is very inexpensive to run. I'm running it on my computer right now. I'm dedicating like a gig of RAM or less for it, and I'm throwing gobs of data against it. Did you have another one?
Could any of the data that's stored in here be used as some kind of an audit
I know where you're going. Answer is yes, but the problem is how you store that data in a, well. So I didn't get to demo this, but one of the things that we're doing is we are shoving logs into Elastic, Kibana, and Solar, like server logs and FileMaker logs. Why? Because it's instantaneous to look for stuff in Solar Elastic. But if you can do that, you can do audit trail logs into Solar or Elastic. And why? It's instantaneous, right? And it persists over time. And because it's a document-based system, it doesn't actually delete stuff, right? It just adds a new thing on top. And so in theory, you could kind of roll back and see the changes over time. The problem is that I think the UI for that is a little goofy. Yeah, you need something like Kibana or some other visualization service to really take advantage of it, and then that gets into the weeds. So yes, if you want to do that kind of stuff, I would prefer something like CloudWatch on AWS or similar technologies. CloudWatch is Amazon, so kinda, yeah, not really, but cheap enough. Right. Other questions? All right, if you guys want to find me, feel free to come up. Talk to you guys later. Thank you.